Good morning, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up 104 is on the screen. Shouldn't take you long. Put away those AirPods, cell phones, and such. Set aside your whatevers that you have. And focus. Today we're moving on. Let's go. Last two modules, last two sections. I think we got this. All right, share with your neighbor your warm-up so you can get the show on the road. All right, good. What are the measures of variation, Briseida? Variance, standard deviation, and range. Okay. So far, so good. All right. So, we need a mean. Pass someone, Briseida. Billy. 10? 10, so we got 10. All right, looks about right. So we need a variance. Pass someone. 25.6. 2. Okay. Standard deviation. Pass someone, Alexa. 5.0 what? 2. Okay. How about range? Pass someone. 15. All right. So, first standard deviation up, first standard deviation down. That's our normal range. So we said it was 5.02. So we are at 15.02 or 4.98. However, we need a z-score. A z-score for the number 13. Share with your neighbor, see what you got for your z-score. And Diego's going to pass it to someone. Diego, pass someone. Joseph? 0.59. So that's like almost 2/3 of the way. So 2/3 of the way on the positive direction. It's about right here. So that's the z-score for 13. All right. Not bad, not bad. Copy the agenda. Warm-up 104, discrete probability distribution, and the home play page 272, numbers 1 through 4 only. 1 through 4 only. And today we're moving on, guys, just so that you know that trying to finish up our first portion of this section strong. And we started last week with the discrete probability distributions, and you did plenty of practice. We did a little pop party on quizzes, and we're going to have a retake on that. I'm thinking either Wednesday or Thursday, one of those 2 days, so we'll go from there. Okay, we good? Thank you for sending in your warm-up. Appreciate it. All right. All right, so let's get started. I can define and compute the discrete probability distribution. I can define and compute the discrete probability distribution. So remind your neighbor what probability distribution was. What was a probability distribution in one word? One word, Chelsea. That's 2 words. Table, yes. That was good, right? That was good. Anyways, yes, table. We're still in the middle of probability. We talked about variables. We're in the middle of discrete. And we said the probability distribution is a table. where X are the outcomes and P of X is the probability, yes? All right, we built many of those. However, today, write this down, we got some formulas. Let's go. First one, mu equals sum of X times P of X. Second one, and third. Copy those down, give some time. All right, we got it, yes? So, remind your neighbor what these symbols stand for. Look up. Start with the first one. Tell your neighbor what this stands for. See if they remember. I'm taking you way back, but we've been using those throughout the entire school year. Chelsea, pass someone. Mu, yes, but what does it stand for? Help her out, Jaden. That is correct. This is the mean. Label that in case you forgot. All right. So let's break down the formula to make sure we see what we see. To get the mean, it says here we find the what? The sum of what? The given number times P of X, which is the probability of X, yes? All right. Remind your neighbor what this one stands for. Jaden, pass someone. Fernando. That is correct. Variance. And of course, everyone, this stands for standard deviation. However, since now we are in probability distribution, what does that mean? That now we're going to find all these within a what? What was that one word? Chelsea. Yeah, within a table. That is correct. So, without further ado, copy example Q. Write that down. And it reads, construct a probability distribution for rolling a single die. Compute the mean, the variance, and the standard deviation. Copy that. All right, so let's put this all together. We started last week, and we did the first part already. Is that correct? Do we know how to build or construct a probability distribution? Yes. So let me zoom in. So, probability distribution, X, P of X. For rolling a die, remind your neighbor what to write on top and what to write underneath. Fernando, pass someone. Yes. And underneath? 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. Okay. So far so good, everyone? Yes? All right. So let's start with our first formula. What is our first formula? Let me write it down one more time. Which is what? Mu. And what did that say? It said that find the sum, in order to find mu, find the sum of what? The given number times P of X. So, let's do that together. Here we go. So, to find the mu, We need to find the sum. That means add everything for each one of these. So watch. I'm going to do the first one. Look up. Look up. What is x on the first one? 1. What is p of x on the first one? 1/6. So I'm going to write 1 times 1/6. Since it says sum, you need to add the next numbers. So what do I write next? 2 times 1/6 plus, next one, 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. So far so good? Yes? All right. Are we done? No. What is 1 times 1/6? 1/6 plus, what is 2 times 1/6? 2 6s simplified is what? 1/3. Are you guys okay? You guys awake? You're like, Mr. Q, it's Monday. So, my goodness, let's go. 3 times 1/6 is 3 6s, or 1/2, plus 4 times 1/6 is 4 6s, or 2/3, plus 5 times 1/6 is 5 6s, and 6 times 1/6, 6 over 6, which is 1. So far so good, yes? All right, mu. We're still working on mu. So let's start with 6s. What is 1/6 plus 5 6s? 6 over 6, which is 1, right? So I'm going to write that one here, 1. I'm going to bring this one also down, plus 1. Now let's combine the thirds. We got 2/3 plus 1/3. That's 3/3, so that's what? 1. And you bring down the 1/2. So all this is 3.5. Are we done? Yes? Lenny, you good? All right. So we're done with the first formula. Let's write our second formula. I'm going to write that in blue. The second one is our variance. Variance, again, we find the sum, but this time we find the sum of x squared times p of x. And then what, Diego? Minus mu squared. So do we have mu now? Yes, we already have it there. Do we know what to do with this component? Yes, so let's do that. Variance is, let's see, what is x squared for the first one? Let's write it out. 1 squared times 1/6 plus, what's the next number? 2 squared times 1/6 plus 3 squared times 1/6 plus 4 squared times 1/6 plus 5 squared times 1/6 plus 6 squared times 1/6, and then minus 3.5 squared. All right, so variance. 1 squared is 1 times 1/6 plus 4 times 1/6 plus 9 times 1/6 plus 16 times 1/6 plus 25 times 1/6 plus 36 times 1/6 minus 3.5 squared. Let's see, calculators calculate. What is 3.5 squared? All right, very good. 3.5 squared. Okay. No one yet? What? What is it? 1225? 12.25. Okay. All right. So, variance. So 1 times 1/6 is 1/6 plus 4 times 1/6, that's 2/3, plus 9 times 1/6, that's 1.5, yes, plus 16 times 1/6, that's 16 divided by 6, that's 2.6, yes, all right, plus 25 divided by 6, that's 4.6, 4.16, let's go, plus 36 times 1/6, that's 6, minus 12.25. I'm going to leave that in parentheses because it's a negative. Variance all right. Compute all that on your calculator so you can give me a number, please. What is it? 2.84. I was going to say this is about 15 minus that, so it should give us something close to that. All right. So, first formula for mu, done. Second formula for variance, done. What is our third formula? Standard deviation. And how do we find that? So basically just take the square root of this, the variance, right? Sum of x squared times p of x minus mu squared. Do we need to do all that work anymore? No, we already have it here. So we take, to get standard deviation, we take 2.84 and we take the square root. So this is approximately, what is square root of 2.84? 1.68. All right, from 1 to 5, I'll come to you with finding the mean, standard deviation, and the variance of a probability distribution. Fives, okay. Couple twos, all right, so let's do another one. Yay. Let me zoom out. All right, so let's go to this one. Number 1. It reads, a talk radio station has 4 telephone lines. If the host is unable to talk, i.e. during a commercial, or is talking to a person, the other callers are placed on hold. When all lines are in use, others who are trying to call in get a busy signal. The probability that 0, 1, 2, 3, 4 people get through is shown in the distribution. So what do you guys notice on this one? They already have it for you, right? So all we need to do from here is find what? mean, variance, and standard deviation. So for this one, example 1, copy the table only. Let me zoom in. There it is. And then I'll give you a head start so you can find the mean, variance, and standard deviation using the same process. All right. So follow the same process. See how you do with that. Copy and go. All right, so there's the work. Here was your table. Here's mu. Here's variance and the work. And here's standard deviation. From 1 to 5, how comfortable are you with this? 5, 4, 5, 4. It's just like work, right? Just put it in numbers, right? All right, let me send you the screen so you can send me those notes. All right, so, and basically that's how it's going to go. Let me just show you one more example. Look up. And it reads, example 2, a box contains 5 balls. 2 are number 3, 1 is number 4, and 2 are number 5. So, check this out. Don't copy this, just check it out. If I was to construct my probability distribution, thinking your noodle, what would you write for X? Yes, 3, 4, and 5. So, what would I write for the probability of getting a 3? Think about it. There's 5 balls. There's 2 of them that are number 3. So you remember what I would write there for the probability of 3. Everyone? Yeah, 2 out of 5. How about 4? 1/5 and 5? 2/5, and the rest is history, yes? All right, so that's pretty much how it is. All right, so with that said, especially those that are following online, there's a home plate for tonight, so I'm going to give you guys a head start. Each of these tables are already there for you, so enjoy. Oh, sorry. I'll send you that screen in a little bit to yours, those of you that are here live, and I'll see you guys later. Bye.